Welcome to this session about k-means clustering in machine learning. So here we'll look at k-means clustering and let's go for the instructions. So it's very easy. First step, it specify the number of clusters. So k-means clustering is a clustering mechanism which is unsupervised learning, which falls into the category of machine learning, unsupervised learning algorithms. So first we specify the number of clusters. So clustering is like when you have a set of data, you need to group it to various clusters. So first we specify the clusters, number of clusters, required clusters. And next we initialize centroids by first shuffling the dataset and then randomly. So we then first randomly we shuffle the dataset and we randomly assign the clusters. Next we select the k data points for the centroids without replacement, and next we keep iterating until there is no change to the centroids. Assignment of data points to the clusters is changing. So if we look at it in a much simpler way, so we specify the number of clusters, let's say 4, and next we initialize the centroids by first shuffling data and then randomly. So that's how we initialize the centroids. So next what we do is we compute the sum of square distance between data points and all centroids. Next we assign each data point to the closest cluster. The final step, we compute the centroids for the cluster by taking the average of all data points that belongs to each cluster. So if we look at the k-means algorithm, so first you input k set of points. So when you have the input is we have a set of points, so that is step number 1. We have a set of points distributed. Next we place centroids C1, C2, C3 and so on at random locations. So we place centroids at random locations. So for each point we find the nearest centroid. So we use the Euclidean distance to find the nearest point. Once we find the nearest points, but we assign these points to the nearest cluster centroid. So after doing that, for each cluster we find the new centroid. So that means mean of all points assigned to the cluster J in previous steps. So if you look at example, it's very clear from the example. We first have a set of data points which is in white background circles. So we have circles, so that means the data points. So if we go to the k-means clustering algorithm, so first step is fulfilled. Now input we have set of points. Yes. So next step is place centroids C1, C2 and so on at random locations. Now we have done it, one in red and one in yellow. So we have placed centroids at random locations. So the second step is placing centroids at random locations in the given data set, so given data points. So next one is find the nearest centroid. Find the nearest centroid. Next one is finding the nearest centroid. So we assign the points to the cluster after that. So we find, so first step we have a set of data points. We assign the clusters we assign the cluster centroids randomly, one in red, one in yellow, you can see. So the next step is you find the nearest centroid. So each data point you find the nearest centroid. So if you can see, so these red ones, the highlighted red dots are closer to the red rectangular shaped cluster centroid. So we have two cluster centroids, one in red triangle. So we initially designed two cluster centroids, one in red triangle, another one is in yellow triangle. So then we assign the data points to the nearest cluster centroid. So you can see those are highlighted, colored in relevant colors. So the data points colored in red are closer to the cluster centroid, which is the triangle of red color, and the yellow data points are closer to the cluster centroid, which is in with the yellow background of triangle. So next step is, when you have the groupings done in the first time, so this is not the end results, remember this is not the end results. Next what you do is, among these red data points, you find the new cluster centroid for a particular group. So let's say for the red data points, you can see the cluster centroid is far away from those data points. If we move the red cluster centroid here as indicated in the arrow, we move it with right side and down, you can find the new cluster centroid. So that cluster centroid is in the middle of all red data points. So you adjust the cluster centroid. So as the next step indicated here, new centroid, that means mean of all points xi assigned to the cluster J in previous step. So we find the new centroid. So we have to do this operation again and again, repeat until convergence. So now you can see the next step. As we move on, we will get a better example. So repeat until convergence. So now you can see the cluster centroids are properly aligned. So this is about k-means clustering. So if we have a summary, first we have a set of data points which we need to put it into various clusters. First we place the centroids at random locations, cluster centroid C1, C2. Next we find the nearest centroid. So each point is assigned to the nearest centroid. So we can use Euclidean distance to find the distance, and once we assign it to the two centroids, we find the new centroid. For example, here first we had data points, then we had randomly assigned to cluster centroids. Next we assign the data points to the nearest cluster. So the red points are to the red triangle cluster, yellow points are to the yellow triangle cluster. So now between these data points highlighted in red, we find the new cluster centroid, which is in the middle or with the mean value of all. We do the same for the yellow. So we do that operation again and again. So that's why it says the new centroid is the mean of all points xi assigned to the cluster J in previous steps. So we repeat this process until convergence, then we get the better results. So that's the end of k-means clustering.